All right. Hello, everybody. That's a confession in the chat. Hello, everybody.
Yeah, that's a bit strong.
Once again, for those of you who haven't seen me before today, I'm Andrei. I used to be one of the main organizers of Ukrainian Rust community, and now I'm kind of like, and I'm helping with this conference as well. I work at Faro Systems, mostly doing Rust trainings. I sometimes contribute to Rust Analyzer and work on client projects as well. And today I'm very, very happy to introduce you all to Luca Palmieri, who is a software engineer at AWS. And in addition to that, is a very prolific blogger, he gives talks at conferences, and he wrote a very, very good book about Rust. Zero to Production in Rust is not only a great book for Rust, for learning the language, but for software engineering in general. I remember about 15 or 20 years ago, I was reading a similar kind of like full stack book about, at the time it was something like PHP and MySQL, and that book gave me so much insight into understanding how web technology in general works. So if you are new to backend development in general, or building backend services, you would appreciate this book a lot more. I'm only salty about one tiny bit at the beginning where Luca recommended IntelliJ plugin over Rust Analyzer. Other than that, it's a perfect book. I really, really like it. It's one of my favorite books I've read. With that said, I'm very, very happy to give you the stage.
Well, thanks a lot, Andrei, for a very nice introduction. And it's an honor to be here on this event. So I'm very happy to be on this lineup today. Now, without further ado, let's get into the meat of things. This talk today is about reasoning about Rust code. So we're not going to be talking necessarily about writing Rust programs and what you can do with Rust, which is certainly interesting. But we're going to be talking about how we can reason about Rust code that we've already written, and more importantly, how we can integrate that reasoning into our workflow to make sure that the code keeps doing what we want it to do. So static analysis and surroundings. And in particular, we'll focus on Rustdoc's JSON format, which is a fairly new feature from Rustdoc that has not been widely publicized. And this talk basically aims to fix that. Introduction for me, for those of you who haven't met yet, I'm a senior engineer at AWS. I previously worked at Layer as a principal engineer. And you can find me on Twitter. The nickname is AlgoLuca. I wrote a bunch of stuff in the Rust ecosystem, workshops, blog posts, crates of various kinds. You can find most of it on GitHub. And I'm also the author of, Zero to Production in Rust. So an introduction to backend development. The title says opinionated, so that's why I recommended IntelliJ, but Rust Analyzer is also very good. Said that, today's agenda is divided into 4 sections: living with Rust, and then macros, Rustdoc JSON formats, and limitations, just to send you home with like reasonable expectations over what you can do with the different things. Okay, living with Rust. Now, familiar scenario that most of you might have been into. You are at work, or you're with your organization, and you need to build a new system. And you are the Rust head in the room, so you debate, and eventually just swear down everybody else and convince them that the new system should be written in Rust. So you choose Rust. A few months pass by, you're hands down coding, building this new system, and eventually you're responsible for tens of thousands of lines of Rust, which make it into your production environment. And this is usually the point in time where you go on your blog, or you go on YouTube, or you go on Reddit, and you say, we wrote our system in Rust, and everybody claps you, and you're happy, and you get karma points. In reality, this is problematic because now you have tens of thousands of lines of Rust, which is very cool. But code is a liability. The more code you have, the more issues you might have with that code, the more issues you might have over time evolving the code base to satisfy new needs. So a question that comes to mind is, how do we reason about that code? Like, you can think of code as real estate, buildings. Now you own a little Rust city, and you need to drive new trains and create new roads and just make sure that Rust city remains nice and flourish. So how do we do that? And let's look at some questions that you might want to ask. So let's assume that you're writing a library, which is going to be published on presentaion, or perhaps it's an internal library that your company uses to do something. Libraries, APIs, so what users can use from your library, are very, very important. They are the contract between you and the user. And you want to make sure not to cause breakage against those APIs, or at least not to cause unnecessary breakage. A particular point of contention is which third-party types are exposed to your API. So your API may expose a public function that takes, for example, a chrono date time. And so if chrono breaks their API and you want to update chrono, suddenly you have broken your API because the breakage permeates to your public interface. And so it's reasonable to expect that you're very, very careful about which types you expose from other crates in your own API. Now, if your public API is a few functions and a couple of types, this is the kind of stuff that you can do manually. Like you review PR really hard, with your goggles on, and you make sure stuff doesn't slip through. But if you have hundreds of thousands of functions, as is the example of the AWS Rust SDK, doing it manually doesn't really scale. Like you need a tool that you can say, I want only these types to be exposed through my public API. And if anything by mistake exposes something new, you want to be warned. So can we do this? Another example is enforcing architectural constraints. So it's very common in backend applications to have hexagonal architectures, also called ports and adapters architecture, where you have a domain core and you have adapters for persistence, so databases, queues, and similar things. And you want your domain core to be isolated from the implementation details. So you want it not to depend on a specific implementation. And you can represent those with modules. And one way would be, we want to make sure that this module does not depend on this other module. Can you do that with us today? Not really. And then we can get into the specifics, which are more backend development type of things. Which endpoints require oath? Does this PR change some endpoints that were previously authenticated to now be not authenticated? Was it intentional? Perhaps, perhaps not. But can we flag it when it happens? Or you might ask, in a big monolith, and you want to do some stuff around the database, which endpoints are accessing a certain table? Like who is actually querying the user's table? And that may be useful to understand the impact of making certain changes. All of these are very, very reasonable questions. And one common technique that you can use in the Rust ecosystem is to encode the constraints that you want to be true inside the type system. This is also known as making illegal state unrepresentable, so forcing code to be correct by construction. Now, this is a good technique, which I generally suggest. We are trying to model your domain and make sure the stuff stays correct, but it's not a silver bullet. Like you can't always do this. Sometimes the constraints you want to enforce are just not amenable to be represented into the type system. Other times you can do it, but man, is it complicated. Like, you end up building these pyramids of traits and the errors are terrible. And, it's possible, but that doesn't mean you should do it. So generally, not a good thing. So when the tools we know fail, what can we do? And it's fundamental. So when you think about, reasoning about Rust code, one way to describe that is metaprogramming. We are programming things. And when I say metaprogramming in Rust, my mind by association goes to macros. That's the main tool that Rust provides you for doing metaprogramming. Rust has two types of macros, macro rules and procedural macros. Macro rules are also known as macro by examples, and they're primarily geared toward code generation. So a macro rule looks pretty much like this. You have the macro name, which in this case is times 10, and then you have the pattern that you want to match and the code that you want to generate if we match that pattern. So you can think of a macro rules fundamentally as a match statement. You're matching a Rust syntax on the left, and you are generating a bunch of code on the right. And this doesn't mean it's simple. There's a lot of different patterns you can match, and then there's design patterns you can use to make certain things possible, TT Muncher and whatnot. So the argument, like the shape looks simple, but you can do a lot of things with it. It's very flexible. Nonetheless, it's primarily code generation. And the problem we want to solve today is, how do I reason about Rust code? I don't care about generating code. I want to reason about the code I have. So this is not useful. Next, procedural macros. These are more promising. Let's look at an example. You have a my function, and this is annotated using the tracing instrument procedural macro, setting the level of the span to trace. Now, what this actually does is something like this. You have a macro, so this is the instrument symbol. This macro takes a bunch of arguments that you can think of it as, function arguments, but for the macro. And then the macro applies to a scope. In this case, the item that the macro applies to is the my function definition. So the entirety of it, from pub all the way to the closing brace. And what this sugars into, so what the compiler does when you use the instrument macro, is it calls the macro function. So this exists in the crate that defines the instrument macro. It's a special function annotated with from macro attribute, takes as input the args, so level equal trace, the item, so from pub to the closing brace, does a bunch of stuff, and outputs out a bunch of tokens. So if you do, the architect thing, when you do boxes and arrows, a macro is a bunch of tokens as input, some processing logic, a bunch of tokens as output. Now, the processing logic is, Rust is just a Rust function, and Rust functions can do a lot of things. In particular, they can do side effects. Now, some people would say that this is a problem, and that'd be right, because you can think of procedural macros as arbitrary code execution at compile time with localized input. So you can do whatever you want inside a procedural macro, and you're getting as input a specific part of the Rust program that's being compiled that was marked with this macro. And when you have arbitrary code execution, you can start to do funky things. For example, you could save the macro input to a file to be analyzed later. So this becomes a way, to demarcate some specific spots in the code base, which then you can put all the way in one place and then do some post-processing. You could also do nastier things, such as, performing network calls. An example of this is you could annotate all your queries with a macro, and then the macro could go and ask the database, is this query valid? And the cool thing about this is that it exists. It's called SQLX. So SQLX is, query macro, takes your query, which is written, as a SQL text query, sends a prepare statement to database. Database says, this query is okay, these are the types of the things, or, this query is not okay. And then SQLX fails compilation or generates code that maps the result. So the fact that you can execute side effects in procedural macro is useful because it allows you to do, interesting things that wouldn't otherwise be possible. What's not as nice is that you can't control what side effects a procedural macro can execute. So that part is a bit dangerous, but not the topic of this talk. Now, all of this sounds very cool, but what you need to remember, and this is the important part, is that you're working with tokens. And what does this mean? So let's assume that you have a SQL_query procedural macro that does some funky things with your query. Now, we refactor the invocation, and instead of passing to SQL_query the actual query, so select start from users, we assign that to a constant, and then we pass the constant to a macro. Well, we just broke it, because the macro can resolve the query token, because for the macro, it just got, as input, a query token. Has no way to know that query is a constant, and that constant is associated to select start from users. The obvious thing would be asking the compiler, tell me what this is, but this is not possible because there is no compile time reflection API. So, tokens in, tokens out. What those tokens means, you don't know. So you have no way to resolve the import part of a function, asking what the input parameters of a certain things are, but just outside the realm of what macros can do today. Now, if you're really determined, as I happen to be from time to time, you could say, well, okay, compiler is just a bunch of Rust code. It exists in GitHub. We can invoke it as a library. So you don't give me the API I want. I just go and take the APIs I need. Now, if you've ever been to the Rust C code base, it's kind of a big boy. Like I think I count 40, 45 crates in here. These are non-trivial. You need to wire them together. It's messy. Like you really need to be extremely motivated to do this. And most importantly, the API surface is massive with no stability guarantees. Like none of these crates, or the few of these crates exist on crates.io. They are just internal implementation details of the compiler. The compiler guarantees that the public interface of the compiler itself is stable. So Rust the language, the standard library, the CLI thingies. But the internal soup that makes it possible, that is as unstable as necessary. So any commit could break some of these internal APIs. And what this means is that if you build your tools around those APIs, you need to put in a lot of maintenance work just to keep your tool building, which if you have limited time, you usually want to allocate that to making progress on the problem you're trying to solve, not keeping up with breaking changes which are undocumented from a bunch of internal crates of the Rust compiler. So generally speaking, strongly advise you not to do this if you're trying to build something that does introspection for Rust. And this is where we get to the interesting part, which is Rustdoc's JSON format. I think the chef Perry is pretty appropriate for this one. Now, if I say Rustdoc once again, mind mapping exercise, you say Rustdoc, I think docs.rs. So like this is the mental connection I have. So it goes at this page, which has the specific, gray on black theme and all this stuff sorted in the way my brain has learned to be wired in the past 5 years. Now, once again, docs is in others because we're architects. Rustdoc, Rust creators input, Rustdoc processing, HTML is output. And somebody was very smart thought, well, why don't we just use different formats? So instead of doing just HTML, we could do JSON. And the cool thing is that it's the same information as docs.rs, but it's in a machine parsable format because the HTML is geared for browsers. So you could scrape it and try to, find things in there. Once again, not a great thing because that changes all the time as it, suits best the representation from a visual perspective. JSON format instead is a lot nicer because it's meant to be machine parsable for tools. It's currently a nightly, this feature, so it's not stable yet. The RFC dates back from June 2020, but it's one of those nightly features that has a clear path to stabilization, is in a very good state. Like I've been using it for the past 12 months. It works. Like it has a few bugs. They're not major. Most of them have been fixed. The team is very responsive. So it's in that phase of nightly, which is like using now to give feedback before we stabilize it. It's workable. So don't be afraid. You can try it yourself. So, you go cargo plus nightly to tell Rustup that you want to use the nightly toolchain. Rustdoc, I want to document my library. And I want the output format to be JSON. And you pass -z unstable options because you want to use the special options that are nightly only. So that's just a way to say, I know what I'm doing. Let me do it. If you do that, you get a JSON file. It's in the target folder. I think it's going to be target/doc/ the name of the library you're documenting. Now, let's look at an example. So what happens if I look at a struct in the JSON representation? And I'm going to use a struct from Cargo Chef, which is a tool I maintain. So target args, this is a bunch of logs, benches, tests, examples, or targets that tell Cargo Chef what it needs to compile. If we look at how this is represented in the JSON, it looks like this. So every item in the JSON has an identifier, which is unique. And that's 0:12:1620. Inside that item, what do we have? We have the crate that item belongs to. Crate ID 0, 0 is a special number. It means it belongs to the crate for which the JSON documentation was generated. So since we're generating the JSON documentation for Cargo Chef, and this is defined inside Cargo Chef, this item gets crate ID 0. Then is the name of the struct, so target args. The struct is public, so visibility is set to public. This was private, this would be private, otherwise would be different things. And then you have a kind. So you can think of this as a, an algebraic type of enum. And the kind switches on the possible type of items that you can have in there. In this case, it's a struct, so kind contains struct, and then inner contains the things that are specific to structs. Obviously, you have different kinds of structs, so we have another, enum in there, which is once again kind. So you have unit structs, which have no fields. You have tuple structs, which have fields without names, and you have plain structs, which is exactly what we have here. So structs with fields and types. This is a plain struct, which has a bunch of fields. Each of the fields is its own item. And then, this could have generics, implementation points at both methods on the type and traits that the type implements. So, everything that you want to know about target args, it's here. Like it's encoded and, it's linked together in this graph of information. And you can follow the IDs. It's like following the stars in Peter Pan. And you go there and you say, what are the fields? And you can, for example, get benches. So once again, benches is a field on a type defined in this crate. So it's crate ID 0. It has its own identifier. It's public. The kind is struct field in this case because it's a struct field. And since it's a struct field, we want to know what the type is. Type, once again, is an enum, which has various options. This case is a primitive and it's a Boolean. This is quite cool. Now, parsing the JSON can be tiresome. So good news, you don't have to do it. A tool does it for you. It's called Rustdoc types. Is maintained by the Rust project. So every time they release some changes to the JSON format, they release a new version of Rustdoc types to create IO, and it parses the JSON into structs. So you just go here, say, parse the whole thing, and then you're working with this kind of like enums and structs. So it's all very, very, very simple and streamlined. Now, the other thing that is really exciting is that this thing is versioned. And this is very, very, very important. Like the reason procedural macros can do so little, as in like the reason they're forced to work with tokens, is because Rust as a project doesn't want to stabilize internal implementation details of Rust the compiler or Rust the language. So if you provide, for example, introspection APIs like reflection, compile time, and then you need to introduce a feature that will break one of those introspection APIs, what do? Is like, is the compile reflection API, is that 1.0 forever as stood? Can that break its own, interface? That's a tricky one. So by reducing the scope of that API, reduces the chance that they need to be broken. Rustdoc JSON took this into account from the beginning, and so it has a format version, which means it is stable enough to be useful. So, you can encode what format versions you support, and your tool can reject inputs based on that. But it also leaves the door open to evolution. So once this gets stabilized, they can still release new format versions, obviously at a lower pace, because you don't want to break everybody every 6 weeks. But it leaves that door ajar. So that's a very good mechanism. Now, as I said, Rustdoc's JSON isn't nightly, so it's not stable yet. But using nightly for tooling, which is not exactly using nightly for the code you're compiling that runs in production, is a much lower bar. And so a bunch of tools already exist that use Rustdoc JSON format. And I'm going to go through some honorable mentions. Number one, and probably the one that every single one of you should check out, it's called Cargo Assembler Checks. It's a tool to verify if a new version of your crate contains breaking changes. What it does is very simple conceptually. Generates the JSON documentation from the last release version of your crate, generates the JSON representation for example, your PR code, and then compares them. And it's like, is there any change here that is a Semver major breaking change? Like, have you removed the public field? Is something that used to be send and sync no longer send and sync? So also, the tricky ones that you might not think about because they're not obvious when you look at a PR. And this should be part of your CI if you maintain a crate on Crates.io. Like, it's a very good idea to add this to your checks so that you can more easily avoid releasing, unintentional breaking changes on a patch or minor Semver bound. Another one is cargo check external types. This is used by the Rust AWS SDK to solve the problem I mentioned at the beginning. What types are exposed from third-party crates in my public API? This is part of the AWS Rust SDK CI and makes sure that they don't, unintentionally start depending on additional third-party crates beyond the ones they've explicitly opted into. This, once again, is built on top of Rustdoc JSON. Generate the JSON docs, walk the JSON, find all the types that are exposed that have crate ID different from 0, and verify if they are allowed or not allowed. And then there is something I am building personally, which is Pavex, a new Rust web framework, which is not available yet, so you can't go and install it, and that's by design, and that's because it's very alpha and partially working, but not recommended for any usage at this point in time. And what this framework does, which is very different from others, it has dependency injection, which some of you will say cool, and some of you are saying, ooh, dependency injection. But the cool part is that it does it at compile time. So it doesn't happen at runtime. We look at your graph of dependencies and then generate the code that's going to run at runtime and just output it to a file, and you compile it as a normal crate. So it has absolutely zero runtime overhead. And since it does this dependency injection at compile time, can do some interesting optimizations that wouldn't otherwise be possible. The way it works, well, it's not very simple, but conceptually, you specify all the constructors, the request handlers for your API. So you say, this is how you build a path, this is how you build an HTTP client, this is how you build a logger. And when a request comes at this URI, I want you to invoke this request handler. And then Pavex build a call graph, which is what you see represented here. Once again, boxes and arrows. So stream file, request handler. We look in the Rustdoc JSON and say, okay, what are the inputs to this? Okay, the inputs are request body, path, logger, and HTTP client. And for each of those, then we go, do we have a constructor for those? Cool, invoke it, add a new box, add an arrow. And then those themselves might have multiple inputs. And we do this process recursively. Rustdoc JSON, what are the inputs? Okay, do we have a constructor for those? And go. And so this generates a code graph, and then we do code generation by walking the graph. And, bunch of interesting things to be done here, such as auto concurrency and other things that are more in my mind than implemented at this stage. So I mention it because it's what I spend my evenings on. Cool. Now, I spent the last 15 minutes probably hyping up Rustdoc JSON. And so, some of you might think this is the solution to all problems. And so this section is intended to throw a bunch of water on those expectations and, bring you back to a more sensible level of enthusiasm. So it's not a silver bullet, and let's look at why. First of all, a lot of information is in there. That doesn't mean it's easy to use or it's possible for you to make sense of it. As I showed before, structs and enums will have links, for example, to the traits they implement. But if I give you a specific type, like, path my struct, does this satisfy a specific trait bound? This is a very complicated question to answer, because the type is generic, so there might be a trait implemented for it, but that trait might be conditional on the generic type implementing some other stuff or having certain, lifetime parameters. And so before you know it, you are implementing the Rust trait solver, which, trust me, is a very complicated piece of code that you probably don't want to be re-implementing unless that's your own project. And so, yes, the information about traits is there. You can do some basic reasoning about it, but like going anything beyond that is really, really difficult. The second thing that is missing is that anything that is not visible through the API of your functions is invisible in Rustdoc, because Rustdoc is designed to do documentation. So documentation care about your function signature, the input types, the output types, this kind of stuff. What happens in the body? No idea. So if we go back to the question that I was asking at the beginning, which is, does module X depend on module Y? We still can't answer this question with Rustdoc's JSON. We can answer a weaker question, which is, does module X, do functions in module X or types using their public API any type from module Y? We can answer that question because we can check the API. But if something happens in the function body, like invoking a function defined in module Y, we can't see it. So question still unanswerable, which is sad. But generally speaking, I like to think of Rustdoc JSON as the beginning of giving tools to the masses to introspect Rust code. So not everything that needs to reason about Rust code needs to happen in the compiler, and you don't have to go and build a new Rust front end if you want to reason about Rust code, which is fundamentally what Rust Analyzer did, which is cool, but also like a gigantic, massive project that you probably don't want to do yourself. And there are more tools that are coming online in this space. I think there are initiatives around stabilizing mirror, so the intermediate representation, or some variation of that. And I think getting tools to reason about Rust code is going to be critical to get Rust to succeed at scale. As people write hundreds of thousands of lines of Rust, they will need tools to manage it. And some of these tools will be in the open, some of these tools will be built specifically for their projects. So they need ways to do that building themselves. And I'm optimistic they will see more of this. And this talk is just an opportunity to get more people building and foment interest. And that interest will be able to lead to more things, and everything will be beautiful. So this is the end. And if you have any questions, this is the moment.
Thank you so much. Thank you. A lot of applauses. We do have some questions, right? And turns out I'm a co-host, cannot put my own questions in the list, so cannot see mine. So I won't be asking them in a particular order, but just in general, right? I think you've touched what's the advantages of JSON compared to HTML. I would add to that, is there any information that we can see in Rustdoc that is not available in a JSON at the moment?
Not that I'm aware of, like from my own experiments and what I've done, and also from how I understand it as Docker base is structured, that's pretty much information parity. If there wasn't, I think that would be considered a bug by the maintainers of Rustdoc, and as much, be fixed, reported, given enough volunteer time to do it. So from that point of view, I would say it's the same.
That's cool. You've mentioned that the JSON format itself is versioned. How about the Rustdoc JSON crate? How stable that crate is? Does it change often? Does it break compatibility often, etc.?
That changes when the format changes, generally speaking.
Yep.
It might change more often because, some things that are non-breaking from, a JSON wire format representation may be breaking from a Rust crate representation.
Yeah, that's what I was wondering.
But my experience is that it doesn't break very often. Like the only times where I notice the version bumping is because they've made some breaking changes that bump the format version. It's also important to notice that it's a very big crate, as in the format is big. It encompasses a lot of types and information. And realistically, most of your tools don't use the entirety of it. Like, for example, Pavex, touches a lot of functions and methods and, struct fields. Perhaps doesn't touch, a bunch of other structs in there. And when I usually bump Rustdoc types across breaking versions, I need to fix a couple of things, but nothing that I can do in under 30 minutes. And it's a big code base. So it's good, so to say.
That's cool. Do you think in future, this JSON representation and this crate can build a way to compile time reflection in general, as a compiler feature?
I don't know.
Or do you think it's better to keep it as a separate tool?
So I would enjoy having compile time reflection. It would make a lot of my stuff obsolete, which I see as a win. It's not easy to do it on top of Rustdoc JSON. I would consider that to be slightly, a little bit of a hack, but a sensible one given a restrained set of objectives. If you wanted proper reflection, I think that would be introduced in the actual Rust C itself, instead of being an appendix of the documentation tool. What I hope is gonna happen is that the project, so the Rust project, is gonna see what is gonna be built on top of Rustdoc JSON, realize that there's interest here, and there's legitimate use cases that require some of this functionality. And then from there, we can open a conversation around, should we prioritize this? What should they leave? Should it look like? And potentially make their way to a proper compile time reflection API. Now, compile time reflection API is a complex topic for a variety of reasons, especially with respect to macros, because if you are inside the macro and you want to, ask, for example, what is the type of X, that assumes the type resolution has already happened. But then your macro can generate a bunch of code, and that might change the results of type resolution. So, it's a very messy situation.
Yeah.
What I'd like to be able to do,
macros. Yep.
Well, what Rust Analyzer does, for example, what Pavex does is we don't operate inside, the process of compiling the crate. What we want to do is we want to do reflection on a compiled crate. So as the unit is finished, I want to ask questions around that unit, which asking the questions can change the answer type of thing. Like the observer doesn't influence the result, which I think is a simpler problem to solve, and perhaps more about, a matter of finding the right APIs and seeing how those integrate in the right places.
Yeah. People who are fascinated with proc macros. Sergey asks a very, very interesting question. Is there a way to design a macro in such a way that people could potentially extend the behavior of a macro with the functions that you provide somehow? Not only as a sequence of attributes, but something more elaborate. And I don't think there is an easy way to do that, to be honest.
Not that I'm aware, unless you're willing to commit deep crimes.
I'm thinking at derive macros in particular, right? They allow you to expose certain attribute macros. So you could potentially have, and in general, using attributes, you can give function names. There is no way to call this function anyway. So, but you could potentially do an FFI call, do I don't know.
Yeah, I mean, you can invoke Rust Analyzer in a separate process and ask questions, about the code. But then you get a little bit of a like, loop situation, and it's brittle. Like, I think that's the main point. It's very brittle. Like, there's a universe in which I could have implemented PAVX on proc macros, but like the mindfuckery level was reaching over 9,000, and I was like, this is just feels very bad. So you can do complex things. I think Debbie is an example of like implementing something that looks very similar to like that call graph on top of macros. But that code is not straightforward, not easy. I invite you to have a look at what that looks like.
Yeah, I got on a side note, I got a note that a next talk is starting. So if you want to go to the next talk, which is Alexander Mikhailenko, Evolution of Blockchains Written in Rust, you can switch to that room. And we'll continue on with our Q&A. Like my personal question, have you looked at what kind of what kind of data Rust Analyzer can provide you as a library?
But I found it a bit difficult to use. Well, there's two arguments to this. So one argument is, how do you say, ease of use. Like I found using Rust Analyzer as a library a little bit cumbersome, perhaps not as cumbersome as bootstrapping Rust C, but a little bit. I was a bit scared by the interface. Like that one is also big. The other one is there's a slightly different focus. So depending on what type of use case you're trying to serve, you place a different amount of importance on correctness. And I think Rust Analyzer strives to be useful more than it strives to be correct. And that is the perfect trade-off for an IDE. Like I want to provide you, good suggestions and good introspections that work on, 99.9% of the cases. And when they don't work, it's fine. I might just, drop an error or suggest something that is slightly incorrect. For the type of stuff that I'm doing, which is, trying to, for example, understand what your code looks like, and then based on that, generate some code. If you give me if I get a wrong answer, that for me is troublesome, because then I generate the wrong code, and then it's very, very difficult to debug. It's like, why did that code get generated? That's a problem. So Rustdoc JSON as the pro of being correct by virtue of the fact of using part of the same, pipeline of the authoritative compiler that is gonna, do the compilation. So that was one of the reasons why I opted for Rustdoc JSON rather than, power my way through on Rust Analyzer.
Yeah, also documentation. We probably are less documented than Rustdoc JSON.
Yes.
Yeah. So, right. Any ways to improve documentation for macros in general?
In what way?
Yeah. I don't know, like any macro in its core is a function that takes a sequence of tokens and produces a new sequence of tokens, like you said. So you're essentially documenting this function behavior, and then it's up to you. Markdown is a very extensive format. You can put stuff in.
Yeah, so the issue with proc macros, in generally speaking, and this is the way I conceptualize them, is a proc macro is a mini compiler. And the proc macro is defining an arbitrary DSL that may look like Rust, but it's not necessarily going to look like Rust. So if you look, for example, at some of the front-end frameworks that you can find around, like U and Sycamore and a few others, they implement their own version of JSX, so JavaScript embedded into Rust. That's a proc macro that doesn't look like Rust at all. So a way to improve documentation, as in providing tools to macro authors that make it so that the documentation that they get is better out of the box, in my opinion, relies on providing additional structure to that macro. So instead of looking at the macro as a way to say token in, token out, and no introspections, if you say, okay, this macro expects an input that is structured in a certain way, and then by putting that structure in, I can auto-generate some documentation because I know that this is going to imply certain parsing behavior. then that is the way to provide better docs. Like fundamentally, and this is true for any kind of project, the more structure I know that your input or processing respects, the more I can do for you. The more unstructured is the interface, the more freedom you have as an implementer, the less I can assume about what you're about to implement. And so, token in, token out is the most unstructured possible interface. Because like arbitrary behavior is possible in the middle. While macro rules, for example, like why they're, for example, so much better in terms of auto-completion in the IDE, as an example, is that they're much more structured. Like, they can't do funky things. You can cache the results as long as the input is the same, because they're going to be deterministic. And, all these assumptions allow tools built on top of them to make assumptions that allow them to support better. And so I wonder if perhaps this is a question which I think was raised in the past, if we should have multiple proc macros interfaces at different levels of abstractions, that when you use something that is more structured, allows you to get better docs and better auto-completion out of the box than the super powerful interface, which is the current default, but then, leaves everything to you. And this goes beyond docs. This goes about error handling, recovery, and a bunch of other stuff, like everybody having to implement their own parsing and, scene not being part of the standard toolkit and so on and so forth.
Yep. Yeah, macro story in general, like it's there, but it's not, and it's not I would say it's not a premier. The support level is not premier compared to the rest of the Rust code.
It's an MVP, which you can you can do a lot with, but it's not perhaps in the end state.
Yeah, I'm probably better positioned to say to talk about like a proc macro work in Rust Analyzer. We try to isolate this part of Rust from the rest of your code base. So everything related to macros is handled by a separate sub-process, which is also part of the reasons why it's very hard to do Rust Analyzer support in some web IDs or something, because in web IDs, you usually compile Rust Analyzer to WebAssembly and you run it as is. However, because everything related to macros is runs in a separate process, you also have to compile that, and then you have to, on your website, you have to somehow connect those two WebAssembly modules together, and not everybody has a good story supporting that kind of behavior. And why we do it this way, because proc macros break more often than Rust in general, like because internal representation for tokens and everything can break more often. So what happens sometimes is that you wrote a macro which is so complicated that some stuff around it starts breaking on the IDE side, on language server side, and instead of like your macro killing the whole Rust Analyzer process, it only kills a small sub-process which is instantly restarted. So that's the story there, right? All right, so people are excited about your framework. Let's see, store the layouts of structs. Oh, well, this is an interesting question. Can you get like fields representation? Can Rustdoc help with FFI, understanding how like certain fields layouts are done in this in a struct, etc.?
Oh, that's a nice question. Well,
Yeah.
let's do some live answering. So the way I would go about answering this is I would go into Rustdoc types, which is here.
Yep.
And let's go here. And then, this is an item, which is what I was showing during the talk. And then the item inside is an item enum, which then is going to switch over the different things. So if we're asking, for example, about layout, I would go into this, which is a struct. Struct kind then contain different types of structs. And this doesn't seem to have any information about layout. So all of this looks very boring.
Well, like representation is usually done using wrapper attribute.
Yeah, like, Rust-C, like, what is it, transparent, of like...
C, transparent, and SSTD call, etc. I'm just
so it
thinking...
should be on the struct level. But
yeah, on if it's an attribute, it could be not on an item, but maybe item has some links.
Yeah. Oh, well, no, actually, you're right. So yeah, there's this app thingy, which is like attributes.
Yeah.
So it's probably here. So for example, this one you would look for something like in line.
Yeah. So you would search for this.
And then parse it out.
Yeah. Does it provide you the string itself, or is it an ID that you can go in the JSON?
No, I think it's a string itself. So I don't think attributes get, special handled. So every attribute, which I think is basically every sequence of hashtag, and closing brackets, is an entry into this vector. And then inside there, you gotta parse it out yourself. So bit manual.
Yeah.
But possible.
Yeah. Bogdan mentioned another language called Nemerlang, which I remember being a thing that actually does multi-level macro expansion. And for different levels, you get different mechanisms, which is cool. I know Zig is currently like experimenting a lot with compile time execution and trying to sidestep the whole thing by giving you whole compiler instead of like sub-compiler for macros, which is also interesting. We'll see how it goes. And finally, a few questions like, is the new book coming?
Well, there's no new book in the making at this point in time. And I can expand on that. Like fundamentally, I write books about stuff that I know well. And, to know a subject well, you got to spend time doing it. So Rust Zero Production was the synthesis of a few years teaching backend development to people in Rust, and then, collating all that material as one book. The book that I have in mind that I haven't started writing, and I'm not going to start writing probably in the next 6 to 12 months, is about running production workloads. So advanced patterns, troubleshooting mechanisms, way to do things, perhaps a bunch of concurrency. But I think it's premature to write it at this stage. I want to, work on some of those things a bit more, see how they go out, do a bunch of talks, do a bunch of blog posts, and then once I have enough material, that might be collated again into a book form, or perhaps not. Who knows?
Yeah. And people ask where you got all these pictures of cute crabs.
It's here. So as attribution, if you look for Esther Arzola as the designer, you can find all the pictures. They're Creative Commons licensed, so you can use them too, as long as you quote the author.
Yeah, right. And I really, on a personal note, I really liking everything you write about PAVX.
Oh, thank you.
Just gives another perspective into like how can we make Rust tooling, which is not generally Rust tooling, but very specific to specific domain. I think there is a lot of potential in that area. And you are one of the pioneers. And thank you for doing that. Even if the framework itself is not popular, the work you do in describing everything, it's amazing. And I think every other framework would be jealous of having something like this that you try to build. And I'm looking forward. It's probably going to be like the best framework to, even if it's fast, it's going to be the best framework, period. If it's a bit slower, it's going to be the best framework to learn Rust, and probably to run production as well, because Rust is fast enough for many people.
I mean, the idea is that it's going to be fast. And I haven't run benchmark. I would argue it's going to be faster, but don't quote me on that until it's true. And the idea should be easy.
Yeah,
we'll see. Give me 6 months, and we can have the conversation again.
We're not really like in a hurry here.
Well, I am. I want to see it done. It's so difficult to do a project for a long time, and then people can't try it, and you can't explain it to them, because if you use it, it's a bunch of sub clicks, but if you just think about it, it doesn't. So I'm like, I want to get it to a state where people can use it. So working on it hard.
Yeah, that's great. That's great. All right. As long as we don't have any questions in chat or in Q&A, I think we are done here.
Nice. My pleasure.
Thank you. Thank you so much for coming over. It's a very interesting talk. My favorite talk of the day. Thank you so much.
Thanks a lot.
All right.